Hi, this video is going to walk you through how to find and use math manipulatives on Google Chrome. Actually, you could probably do this on any web browser, but since Chrome is our preferred browser, I'm going to show you on Chrome. The first thing I'm going to do is to start at a new Google page since I don't know the website for the National Library of Virtual Manipulatives, but I've heard they're a great site. So I'm going to search up in my Omnibox for the National Library of Virtual Manipulatives. And once I make that search, I will find the results at the top and click on it. If you think this is a tool you might use later, you can save it to your bookmarks by either hitting the star on the end and categorizing it, or if you already have folders created, you can grab this tool and drop it in a folder to save for later. Alright, so now that I have it saved so I know I can access it again later, I am looking at the tool and I see that it has a matrix. The matrix lists the domains for math and our different grade level bands. I'm looking for a tool that can help me out in grades 3 through 5 in numbers and operations. So I'm going to click in the area of the matrix that matches up with that. Wow, there's a lot of options here. Okay, so I want students to practice modeling addition. So I'm going to use this tool called Base Blocks for Addition. When I click on it, it says that my Java is out of date. The truth is it does need updated, but you don't need to update it to make it work. So just say run this time and get back to me later on that. Java updates are something that Walt will install for you. You don't need to do it yourself, and the tool will work just fine without the update. So here I have some columns set up for thousands, hundreds, tens, and ones, and I have a problem off to the side that says solve this problem. So the idea here is to get students to group things into tens to see them in tens and ones. So to group it into tens, I'm going to tell my students to drag from one side to the other until they have enough to make a 10. Once you have enough to make a 10, then you click and select the entire group. It forms a 10, and once you move it over to the 10, you've solved it as one 10 block and two 1 blocks. Let's look at another problem. This problem is asking what is the solution for 6 plus 8? So I'm going to drag two 1 blocks down to the bottom and then select them all to create my 10 and move it to the 10 category to get my answer of 14. Here's a more complicated problem. Again, I'm going to move my 1 down to the 9, group them together as a 10, and once I do that, you'll see that it carries the 1, showing the concept versus the procedure, and then I move my 10 over into the correct column and get my answer of 90. What happens if I incorrectly perform a problem? Well, it's not going to give me the answer until I properly perform it. It's not going to show me any steps or cues or hints, but that's somewhere where maybe in class you can form groups to work together or direct the students to come ask you if they're not getting what they need out of that scenario. So up here I have 314 represented, down here I have 576, and I need to start combining. I move my 4 into my 6. I group those. Again, here's my 1 being carried. I move it over and my problem is solved. Let's look at one more tool. Why don't I go back and we'll look for a tool for, how about geometry in pre-K through 2nd grade. I'm going to click on that domain area. So here I'm using the geometry manipulatives for grades K through 2. Let's select congruent triangles. Again, it's going to tell me my Java's out of date, but I'm going to run it this time and tell it to ask me later. In this situation, I get segments of equal lengths of blue and of red. The directions state, connect the blue segments together to make a triangle. Do the same with the red segments. So I can move my segments together, being able to identify the color that goes with one and adjust it with angles until they meet together. Once they meet together, my triangle is filled and formed. Let me do my blue triangle here. And once I'm done, I can flip the triangles so I can compare the angles to one another and see that they are similar. Over here on the side, there are also directions that help describe the different types of triangles and the different types of lengths that you can use in order to get congruent triangles. So I think that there are pretty much endless numbers of opportunities for learning here, and I certainly can't demonstrate every single option in one short tutorial, but this is a great tool to possibly look into and consider how you might use it in your classroom, either to model to students or allowing them to model back to you. If you have any questions about this tool, please give me a call.